Hi, today we're going to look at continuous probability functions. We've talked about discrete random variables before, so now we're going to look at continuous random variables. And a continuous probability distribution graphs as a curve that's called the probability density function. So instead of a table, since this is continuous, I can't list all of the values in a table, we use a curve or a picture. And the area under the curve, which is called the cumulative distribution function, or the CDF, is used to find the probability between two values. So we have some properties of the cumulative PDF. The area under the curve and above the x-axis is 1. And we look for probabilities of intervals of x, so not just x equal to a number, but x between two numbers. And the probability that a is less than or equal to x, which is less than or equal to b, is equal to the probability that a is strictly less than x, which is strictly less than b, or any combination of the two. So when we're talking about continuous probabilities, whether it's equal to or less than or equal to or greater than or equal to doesn't matter. The answers are all going to be the same. And these are equal to the area under the curve from a to b. And then lastly, the probability that x equals some number is 0. So as an example, we're going to let f of x equal 1/2 x from x equals 0 to x equals 2. So we're going to check to make sure this is a true PDF. So what we're going to do is we're going to graph it and then figure out the area under the curve. So the graph is this really nice triangle. And to find the area of a triangle, it's 1/2 b times h. And the base is 2, and the height is 1. So the area is 1/2 times 2 times 1, which is 1. So the area is 1, so that's what we really need, which is great. So we're going to find the following probabilities using the PDF from the previous slide. So if you didn't, you might want to rewind a little bit and draw out that picture so that you can see what it is that we're looking at. So the first thing we're going to look at is the probability that x is less than or equal to 1. So the area under the curve from 0 to 1 is a triangle. It's half of that triangle that we had in the beginning. The base of this triangle is 1 and the height is 0.5. So the area, which is also the probability, is 1/2 times 1 times 1/2, which is a quarter, which is 0.25. What about the probability that x is bigger than 1.5? So if you go back again to that triangle, shade in the area between 1.5 and 2, you'll see that we have a trapezoid. And the area for a trapezoid, if you don't remember, is 1/2 times the base times the sum of the two heights in this case. So h1 and h2 are the two different heights of our trapezoid. And if you look back at the picture, the base is 1/2 and the different heights are 3/4 and 1. So I get 1/2 times 1/2 times 3/4 plus 1, and that equals 7/16. So the probability that x is bigger than 1.5 is the shaded area, which is 7/16. So just a little bit less than 1/2. And then as our last example, what's the probability that x equals 1? So again, part of the continuous probability definitions is that the probability that x equals a single number is always 0. And if you think about it graphically, that makes sense. The area would be a straight line, and that a straight line has no area. So the probability and the area are both 0. So this is the end of the section. It's just a basic introduction to continuous probabilities. We're going to look at a couple cases of different types of continuous probabilities in the coming sections. So again, this is just a basic, very basic understanding of it. So let me know if you have any questions, and read through the section, and good luck.